Okay, welcome everyone to this crash course on lean process design or mixed model line design. So we'll be spending time together talking about this critically important subject, how to design a lean process or how to design a mixed model line. I'm Richard Ron.
I'm Gerard Leone, and if you're a lean professional, this is a critical piece of information for you because when we talk about lean, we focus primarily on the elimination of waste and on kaizening a line to perfection. And sometimes that is very, very difficult to achieve. The best way to achieve high performance on a line is to design it right from the get-go.
Difficult, and it's the most expensive way to do it.
And
fixing it later is always the most expensive route you can take.
And it would take forever.
So we want to avoid that. So we're considering this skill as something that every lean professional or manufacturing manager, or really anyone involved in manufacturing, needs to have. And we're going to walk you through the process. It is a step-by-step methodology that you can learn and apply in your factory or in your company. It doesn't have to be a factory. We'll talk about that in a little bit.
And our goal is to walk you through a set of steps, practical steps that we have proven over and over and over, and that we teach in our 3-day workshop. So this is 3 days of information in one shot. So be ready for it. We're going to jump in.
Here comes the fire hose.
Exactly right. We're going to jump right in.
So have your pen ready, have a notepad ready, because we'll be conveying a lot of really valuable information to you. So let's start with a definition. Mixed model line design. What does that mean? Well, you can go online, you can do a search on mixed model line design. You'll probably find us associated with that term, but let's define what we mean by that. So mixed model, we're talking about more than one model. And certainly the days of Henry Ford, the Model T Ford, you can have it in any color you want as long as it's black. Those days are long gone. And so today, if we're building products, it's not one, it's a family of products typically, with differences, different sizes, different options, different capabilities. And we can't just build them on their own lines. We have to combine them into one production environment. And so that's the mix part of it. We want to mix different products and build them using the same resources. And by line design, we mean a production line. So that could be as simple as a cell, a few workstations, a few number of people, or it could be something as ginormous as a automotive assembly line with literally thousands of people contributing to the building of this product.
And we have seen both environments. We have design lines with 5 workstations and 3 people, 1 machine, and 4 workstations attached to that machine. And we have designed lines that build enormous tractors that, again, hundreds of people work on them. So it applies to all those different environments. We know you're going to have questions as to whether or not it applies to your environment. We're going to do the best we can to proactively answer those questions. But let me start with a point that I think is really important, especially for those of us that believe and strongly support the concept of lean manufacturing. This idea of the pursuit of perfection through continuous improvement. Great concept that at no point in time we mean to dissuade you from pursuing a lean implementation. But some time ago, I believe like 3 years ago, Dr. Womack came out with a really revealing letter right before, probably 6 months before the end of his tenure. And in this letter, he intimated that, well, maybe through all my talks about Kaizen, maybe I have been misleading you. Why? Because Kaizen is not a way to fix a badly designed line. You should start with a robustly designed line and improve from there. So what we're about is taking that first step function in performance through line design, and from then sustaining that enormous improvement through Kaizen. Kaizen is a good thing. But if you do your own research, you will find that there is a Toyota study that proves that there's a 90 to 10 relationship, 90% to 10%, that says 10% of the financial benefits are going to come from Kaizen, while 90% of the financial benefits are going to come from redesigning a line from scratch. So that is, we're focusing on the 90%. Again, not suggesting that the 10% is not valuable. It is enormously valuable, and you must focus on learning Kaizen, implementing Kaizen, and learning every possible tool and trick around that. We're focusing on the 90%, the mixed model line design, the more scientific part of line design and performance of a mixed model line.
I think Taiichi Ono from Toyota actually said that what is lean? Well, lean is a form of Toyota-style industrial engineering. So that's really what we're talking about here, is industrial engineering kinds of concepts that you can apply. And given how important this is, you'd think this would be more widespread, that you could just go on to Amazon.com and find, a whole library of materials on this topic, and the fact is you can't. So it's relatively rare, not unknown, but relatively rare. So hope you take advantage of this opportunity that we'll be sharing with you.
And if you Google mixed model line design, you're probably going to find us. And I think there is another book that I can quote on that specific topic. And so there is a lot of information. And the other aspect of it, and what is pushing us to move in this direction of sharing more information online, is because we can only catch so many of you at our workshops. We can only do 30, 40 of you per workshop, just not enough to disseminate this very important information. And we feel kind of alone in that, because industrial engineering schools are not teaching mixed model line design, and even if they were, 4 years to learn that would be a little too long. So we want to make sure that we form as many of you as possible, turn you into experts. That's our goal, not just to deliver training, but education and mentorship to ensure that you can become an expert in mixed model line design.
Okay, so let's get going on this crash course. Get ready again to drink from the fire hose, and we'll walk you through this process. Okay, so you may wonder, why are we uniquely qualified to share with you this valuable information? So let me give you a little bit about my background, and I know Gerard has a very similar story as well. But my background started working in a manufacturing company and dealing with a lot of struggle. I mean, a lot of problems, as I'm sure you can relate to. So problems with materials, problems with processes, problems with quality. It was a daily struggle, I would have to say.
Planning, MRP,
yeah,
right?
A lot of issues.
Allocation of materials.
Right.
Boy, was that fun.
Right. And then one day, the VP of our particular group, this was in the aerospace industry, came in and said, hey, boys and girls, we're going to go to a workshop, a training session. It happened to be in our city. So said, fine, anything to get out of the office for a few days. And we went to this class on this very topic. And it was a real eye-opener, not just for me, for all of us in the group. We said, this makes too much sense. This is like, why isn't everyone in the world doing this? We need to go back and do it this way. This makes so much more sense than the kind of struggles that we were dealing with on a daily basis. So we did. I eventually became the lean coordinator at this company. Of course, I'm dating myself. This is pre-lean. The term lean it was just starting to come into use.
Yeah.
So it wasn't even called lean. Flow manufacturing was a more typical term, or just-in-time manufacturing.
Yeah, as a matter of fact, the title of our first book, we didn't want to acknowledge the term lean. We called it The Principles of Flow Manufacturing. That was the title of our first book.
But these days the term lean is pretty much dominated. Lean is the generic version of the Toyota production system, I think it's safe to say. So we're using the term lean today. So spent several years in the aerospace industry trying to apply these very new concepts to us at the time. Kanban and line design, all these things were new and exciting. And then in 1994, I had the opportunity to just take this full-time, become a full-time lean consultant. And I did, which is where Gerard and I first met up. And that was triply exciting, or 10 times more exciting, because now we were going all over the place, all over the world, as a matter of fact, and implementing this in all kinds of industries, including the big boys, right? The biggest company you can think of, probably, or one of the top 5, all the way down to smaller organizations.
And what was at one point in time a once-in-a-lifetime opportunity, like it may be for many of you listening to to us here, the opportunity to design a line became a job to us. Every week we were somewhere else in the world designing a new line.
So that was a great learning curve for us, I have to say. And we've had a chance to do this hundreds, I don't know, probably not thousands, but hundreds of times, right? Hundreds of implementations.
Many line designs
We were the classic road warriors.
Yeah.
Every Sunday or Monday, get on an airplane, come back on Friday.
So what industries can we count? Definitely automotive. We've done this in automotive.
Automotive's the classic,
At
right?
the prime level, and then at the tier 2 and tier 3 levels, definitely we have seen from seats to dashboards to glass. We've definitely seen this in aerospace. As a matter of fact, I think we have by far the highest number of line designs in the aerospace industry for the tier 2 and tier 3 levels, right?
I mean, Boeing is a big fan. Boeing has been to a lot of our classes, but below that, at the sub-tier level, the challenge with aerospace is that it's not the same volume as automotive. So we have to apply these ideas in a little different way. They're not building millions of airplanes. Right?
Exactly. And of course, the idea of having a roadmap is to set the foundation. From that point on, you have to learn and adapt. As a matter of fact, one of the industries where this is definitely the way to design a line is agricultural equipment. And we know of companies in the agriculture industry that have taken the idea of a roadmap and developed their own roadmap because they have some unique design challenges. In what applies to automotive with a tag time of just a couple of minutes is not going to apply to someone building a tractor with a 40-minute tag time. And we'll have a chance to talk about tag time and those concepts in a bit. But the place where we're going now, and that's the reason why you have two of us here, is because our company has been divided into two separate practices. Richard leads the manufacturing practice, and after many years of doing manufacturing, I lead our healthcare practice, focused on hospitals. Right now, we're seeing the concepts, principles, tools of mixed model process design applied to hospitals. As a matter of fact, that is our specialty. We are pioneers in the design and implementation of this concept called the invasive center, where you bring all the different invasive specialties under one roof, making it much more efficient, much safer for the patient. Having the cath lab next to the operating room adds an enormous safety net to the cardiac patient. And we have done this several times, of course not as many as lines we have designed, but this is where now the principles of mixed model process design, notice I'm going from line to process design, are being applied. Definitely one area in which we're seeing a lot of growth.
So other industries we didn't mention yet, but industrial equipment's a big one. Medical products, actual medical products, another big one. Electronics, another big one. So if we didn't mention your industry, chances are good that there is a fit for it. But no one said that this was a methodology that you would apply blindly. So we'd have to look at each industry, look at the differences and characteristics, and apply this basic methodology in a way that's appropriate, right, for your industry. But it can fit. I can't think of really any industry where there's no application for this whatsoever.
No, not at all. Now, if you read the word lean in the announcement for this series of videos and you thought, oh, I'm going to hear and learn about standardization of work and 5S and quick changeover, all good things, value stream mapping, all good things, this is not it. we are very focused. We help our clients with all those lean tools, but we are going through a very strong refocusing effort. We're refocusing on mixed model line design and mixed model materials management. Because again, 90 to 10, we want to go for the 90%. We want you to learn the tools for that 90%. So that is the focus of our efforts. And what you're going to see in these upcoming videos, that side, the process side, the mixed model line design. In future videos, we're going to be providing you also with a set of tools and a roadmap for mixed model materials management.
Yeah, so two wings of a bird. One wing is the work that needs to get done. The other wing is the materials you need to consume. This one is the work. Okay, so let's do some actual teaching here. And we'll go back to our definition of mixed model line design, give you a slightly different definition. So it's a methodology, step-by-step method or process that you can follow to do what? Well, to help you design a production line or a value stream, if you want to use that term, that will help you build any product, any day, and respond directly to customer demand in the most effective way possible. Did I get that right?
Absolutely. So that's the idea. We design a line to an assumption of mix and volume, and we're going to talk a little bit about that definition of volume. An assumption of mix and volume, but then we're going to run it to customer demand. It doesn't mean if we decided to build a mix of 1,000 units a day, it doesn't mean we're going to build 1,000 units every day. It means we're going to build whatever the customers order.
Now,
So
if you're
some
following a
flexibility.
process, that's really important because then you have something that's repeatable that you can apply over and over again and get the same expected results every time you apply it, as opposed to just being intuitive or ad hoc. So we're offering you that step-by-step methodology. And I think probably now is a good time as any to let you know that you have a little bonus or opportunity to download a report right on this page. So there should be a button that you can just click on and download a report that summarizes the kind of issues that we'll be talking about, the methodology that we'll be talking about in this
So
course.
feel free to pause the video right now, print that report, and use the white margins to make your notes.
Great
All
idea.
right, so we'll be right here waiting for you.
So here's an example of the kind of things we'll be talking about, just to whet your appetite. In lesson 2, we'll be going through the process step by step, but here's an example of what we're talking about. One of the tools you'll be learning about, and some of you may already be familiar with this, is called Tack Time. So German word takt means beat or rhythm or beat. So the tack time of your production line or of a process would be the beat or rhythm, the frequency of completing products in that line, or the speed of it, if you want to think of it that way. So that's the beat, as if you were dancing. So this is something that we calculate, and you need some data, some input to be able to do this calculation. So the formula is really not very difficult, but there are a couple pieces that we need to have. First one is effective minutes. So how many minutes a day, 24-hour period, do we have to actually do work? Not to go to lunch, not to go to meetings, not to clean up or prepare, but to actually do the work. So that's a value you would need to determine. And not just for the line in general, but for each individual process.
So there is a process, a series of calculations that we will share with you to get down to that number of effective minutes. Starts with if people come in at a certain time and go home at a certain time, say 6:30 to 2:30 p.m., how many actual minutes worth of work can they deliver? Now, those minutes need to be standard work minutes. We're going to have a chance to talk about that too. But think about effective minutes. So if the normal shift is around 510 minutes, meaning 8.5 hours, from there we're going to subtract lunch, and we're going to subtract breaks, and we're going to subtract other aspects of your operation. In some cases, very standard lunch. In some cases, very specific that may be related to some preventive maintenance activities that are going to yield a number that's going to become the numerator of the tack time calculation. Tack time per process. I know that some of you have been misled by other definitions. Tack time of the line, there is no such thing. Tack times apply to specific processes in the line. So that's the numerator. For the denominator, and that is the volume part of it, we need to figure out the volume at the end of the line. That is the output of the line, and for that there will be some research that you need to do. You're going to have to go to your engineering department, to your marketing department, understand your history per product. So if you have a potential mixing opportunity for 125 products, well, there are 125 products that you need to research, history, forecast, understand the variability of all of them. Again, there is a series of calculations that will help you go through, but the bottom line is that you need to have a denominator that is expressed in number of units per day. And that is going to be the other half of our tack time calculation. You're going to take the effective minutes divided by the volume, and with that you will come up with your tack time calculation. Normally we're going to see that in units, in minutes per unit, 2 minutes per unit, 3 minutes per unit. That is that rhythm or beat. Think of a metronome here, right?
And think of a pipeline. So if we're designing this line to flow products, then we calculate something called tack time, and we're designing this pipeline to handle a certain consistent flow of product. So every tack time, we would expect more or less to have a product come out of that pipeline.
And that's going to happen on the average. So there is a concept, a very important concept, tack time, not for the line, but for the process. This is something very different from what you're going to read in other places. We design the line on a process by process basis. Why do we calculate tack time? For fun? No. Tack time, we're calculating that because it's going to be an integral part of the calculation of resources. Resources, people, machine, combination of both. So when you need to know the number of people, the number of workstations for the line, no, it needs to be at the process level. So think about a line that has fabrication, final assembly, test, pack, ship. You need to know the number of workstations for everybody? No, because an assembly workstation is not the same as a test workstation. So the test process is going to have its own tack time because it's going to be affected. Its volume and its effective minutes are going to be affected by multiple different factors that do not affect the pack or the final assembly process. So it's very important that every process gets its own tack time calculated. Then we're going to let you know what are the other elements that go into the resource calculation, and we're going to calculate number of resources per process. So every process, you're going to know the number of people, the number of workstations, the number of machines, and other things that come from the resource calculations. Okay. So we're going to see a lot more of that during the second video. On this video, I want to focus on why this is very important, but we wanted to show you a concept here that is very important, very pivotal to your ability to be an expert line designer.
So go ahead and download this report, put this video on pause if you need to, and go have that in your hands. And next, we're going to talk about some potential objections to this mixed model line design.
Some questions you may have. We're going to try to be proactive in approaching some of those potential objections.
We've had this before. We've heard these questions before. So why don't we just go ahead and answer them and stop playing around, right? So as many of these we can answer ahead of time, the better. So the first question that comes up, very common and common sense, is this sounds, at least so far, this methodology you're talking about sounds very data intensive. But one of the issues with our company is we don't have that data. Much of it is not available. Even the concept of effective hours is not agreed to and not standard. So how could we apply this methodology without that data? You want to tackle that?
Oh, yeah. And the question of data intensity is, well, there is data that is needed. You need to have some of that data. One example that we hear all the time during the classes we teach is, well, we don't have standard work definitions. We don't have the standard work documented. What do we do about that? Well, you may have to do it before you get going with your line design. Standardized work is important, period, regardless of the type of line design you're going to be pursuing. So, yes, are we proposing gathering, processing information, and then reaching conclusions from it? Yeah, but might as well tell you the truth, right? So it is data intensive, but we're going to propose a method and a series of steps for you to gather that information in an organized manner, save it in an organized manner, and draw good conclusions from it so you can have a solid line design. As a matter of fact, for our students, we provide them with a spreadsheet that allows them to go through all those steps one at a time. So that's one typical objection. Data intensive, yes, it is, but it is doable because we teach you to do it one step at a time rather than having an enormous amount of data drop on you all at once.
It's kind of like, is higher education expensive? Yes, but consider the alternative.
Exactly.
So, next objection, we're a process industry, some people might say. So we don't build cars, we're a chemical processing facility, for example.
And the confusion, this is one I'd like to answer. I know Richard wants to go over there, but this is one I like to answer because I also have a background in process industries. And the reason why the folks from the process industry sometimes think this is not for them is because they get bored with us, because they have to listen to all the introductory concepts that for them, they just happen, right? If you're building things that flow in pipes, why are you telling me about flow? My product flows
by
already.
definition. Yeah.
Exactly, flows already. Tell me about something I don't know. But I have folks here that build tractors or build cars or build phones. They need to learn about flow. So that's one of the reasons why there is some confusion about this not applying to the process industry. Absolutely does. But all the flow part, you have it figured out. This idea, this concept that Richard was using a few minutes ago about a pipe, well, you already have that. So there are other concepts that we need to focus on, like once we properly design your line, how many machines do you need? How many extrusion machines do you need, right? All those concepts need to be calculated. After that, you're going to have a different set of questions like, what's the proper batch size? Yes, I use that word, batch. And building one at a time is not an option in the process industry. You can't build one pellet of plastic, right? You have to build a batch. The question is...
Or one bottle of beer.
Exactly.
That's the example we use here in Colorado.
True. The question is, are you going to build one bottle at a time? I don't think so. You're going to have to build a batch. A year worth of inventory? No. There are calculations to optimize batch sizing to make the best possible use, and now you're flowing batches. So does it apply to the process industry? Absolutely does.
Okay, ready for another one?
Yeah, indeed.
All right, another objection, and this is one kind of near and dear to my heart. We're a high mix, low volume environment. So who would that be? Well, aerospace, we mentioned earlier, is a typical example. I don't build that many of any individual product, but I got a lot of them. I mean, we've seen facilities that have literally 1,000 SKUs that they are actually building, but the typical order quantity might be 10 or 20 units.
And they don't get to see the same part number for 6 months.
Yeah, until they get another order from Boeing or from one of their primes, they may not build this product for a long time. So does this apply? The answer is yes, it does, but again, in different ways. For example, we have some rules related to how feasible it is to mix products one after another, building an A and then a B and then a C and then an X and then an M. There's some rules as to how you would do that effectively. One of the rules is you need to have a certain range, limited range of work content time. You can't have a 10-hour product right behind a 1-hour product. You're not going to flow very well. So we have some rules that apply in that kind of environment. And the other one has to do with commonality of process. So how consistent are the work steps and the processes involved? So if you have too much variety there, then your line becomes more like approaching a job shop or a bowl of spaghetti. So does this methodology apply? Definitely it does, but with some slight differences. The other big challenge in a high mix, low volume environment is changeover. So if we have changeover time between products, we definitely can't be going from an A to a B and then back to another A. You're going to be consuming your work time doing changeovers, essentially. So the answer is definitely yes, definitely it's being done, but in slightly different ways. So in this video, we've shared with you the why, and hopefully by now you're convinced, this is something that does apply to us, or at least it seems like it might be, and this is something that's going to be important to us as a company and also to you as an individual. Because remember, as we said before, if you become an expert in this kind of methodology, way of doing things, designing production lines, and production value streams, then you're a valuable person in your company, incredibly valuable, because this is a rare skill.
And this goes beyond degree. And this is something we're beginning to see more and more. Again, not to discourage anybody from getting a degree. My son is going after his second master's degree. Believe me, my wallet can tell you some stories about that. It is
Can't hold down a job.
Exactly. It is very important. We strongly believe in education, but we also see that mixed model line design, which is the wave of the future in manufacturing, is not being taught, and the opportunity to become an expert, to learn the skill that is an opportunity is right there in front of you. It will benefit you as a professional. It will benefit your company, because your company will be able to build any product any day based on customer demand, thanks to your design. You are the key to that 90% benefit, and that's where we want to take you.
So in the next lesson coming up, this is going to be very cool, and you'll want to sit through it. We'll be walking you through the what exactly is involved in applying this methodology. So we'll be taking you through the step-by-step process in detail. So you'll want to make sure to watch that. That'll be released in a couple days.
Yeah, and that is going to be, think about a bulleted list. We're going to take you step by step, and we're going to be walking you through the roadmap that we have developed and that we teach in our 3-day class. So that's going to take a couple of days for it to be released, and it's not going to be available to you until you finish this one. So finish this one, make sure that you take your time to read the report attached to this one, review your notes, and be ready for the next one.
Okay, one more thing. Right below on your screen here, there's a room to add some comments. So questions, comments, yeah, I liked it, or could you tell me more about any specific topic? There's room for you to do that. So please go ahead and do that, especially since you're here now watching it. Go ahead and drop down and add some comments for us. We'll be looking for those.
Yeah,
as well.
take a couple of minutes, help us out with comments, ideas, because that's why we're doing this. We're doing this for you. We want to make sure that we reach as many of you to disseminate this knowledge that is so very important. So please take a minute, let us know that you like it, that you like us to improve something, and give us your comments, give us your questions. We'll make sure to address those in upcoming videos.
Okay, and we'll see you in lesson 2.
Thank you.